Hello viewers, welcome to today's lesson. Today we are going to look at another topic, and that is the periodic table. The periodic table, because there are so many chemical elements in nature. We have about 118 chemical elements at present. Some of these elements have similar chemical properties. They have similar chemical properties. So it will be difficult for us to study them as individual elements. Okay, so scientists had to arrange them, had to group them into families so that it will be easier for us to study them. Okay, so over the years, many scientists have attempted to classify the elements into tables. The most successful attempt was made by a Russian scientist called Dmitry Mendeleev. Dmitry Mendeleev. So Dmitry Mendeleev published the first version of the periodic table, arranging the elements by their atomic weight. So the basis for his own arrangement was in order of the atomic weight. He also predicted the properties of some elements that were not even discovered at that time. And luckily, those elements, some elements were discovered that actually fit into this prediction because he left some gap in the same table that actually accommodated some element that were later discovered. Okay, now in 1913, another scientist called Moseley established a connection between atomic number and the properties of the element, okay, which led to the prediction of the modern periodic law. Because the modern periodic law is a law that states that the chemical and the physical properties of the element depends on the atomic number. So atomic number is the basis for the arrangement of the elements on the modern periodic table. Remember I said that Dmitry Mendeleev arranged its own elements on the basis of atomic weight in order of increasing atomic weight. But the modern periodic table uses atomic number. Okay, so the elements are arranged in the order of increasing atomic number. Alright. Some other scientists also worked between 1940s to 1950s. Lynn Seaborg and other scientists discovered the actinide series. Okay, so as we are going to see the table, we will see the actinide series and the lanthanide series. Welcome back. Now, features of the modern periodic table. Features of the modern periodic table. We have what we call the groups, the period families of the elements on the modern periodic table. Now, the groups. These are the vertical columns of the periodic table. The vertical columns of the periodic table. Okay, and elements in the same group have similar chemical properties. Elements in the same group have similar chemical properties. They also have the same number of electrons in their valence shell, in their atomos shell. Then these are the horizontal rows of the periodic table. The horizontal rows of the periodic table are called period. And then elements in the same period have the same electron shell. Now let's see the statement of the modern periodic table as proposed by Henry Moseley. It states that the chemical and physical properties of the elements are a periodic function of the atomic numbers of the element. What that means is that the chemical and physical properties of the element depends on the atomic number of the element. An atomic number actually means the number of protons in the nucleus of the atom of an element. All right. Now, there's also what we call periodic properties. Periodic properties of the elements. Okay. So we have properties like atomic radius. Atomic radius. What is atomic radius? Atomic radius can be defined as, or can call it a measure of the size of an atom. Measure the size of an atom, or we can define it as one half the distance between the nuclei of two covalently bonded identical atoms. Can be defined as one half, that's 1/2, of the distance between the nuclei of two covalently bonded identical atoms. Or we just call it a measure of the size of an atom. Measure of the size of the atom of an element. So that's atomic radius. So what is the trend? How does it vary across and down the table? atomic radius generally decrease in size as you move from left to right across the table and increases in size as you move down the table. Right? Now, another property is electronegativity. Electronegativity is the ability of an atom to attract a shared pair of electrons onto itself. The ability of an atom in a covalent bond to attract electron onto itself. Okay, and this the ability of an atom to attract electron onto itself increases across the period from left to right and decreases down the group. It increases because across the period table from left to right, the elements are becoming non-metallic, and non-metallic elements normally gain electron. Okay, that's electronegativity. All right, then also have reactivity. Reactivity generally increases down the group from top to the bottom and then decreases across the period. We are going to explain this later as when we look at the table. Now melting and boiling points tend to increase down the group, okay, because of increase in atomic size or atomic weights. All right, then let's see electronic structure of the first 20 elements. That is the arrangement of electrons in the shells of the atoms of the first 20 elements. Electron shells, um, atoms are composed of electrons which are arranged in discrete energy level, and the shells are named from the first after the nucleus as K, L, N, and so on. Now, how are the electrons arranged? The number of electrons in each shell follows the 2818 rule. There's a formula for that. The first shell takes the maximum of 2 electrons, second takes 8, third takes 18, and so on. And valence electron. The electrons in the outermost shell is called valence electron. That is the electron that determines the chemical property of the element in a particular group. All right, welcome back. This is a picture of the periodic table. This contains up to 108 elements. 108 elements. The table is made up of vertical columns and horizontal rows. The vertical columns are called group. We have 1 to 18 groups, while the horizontal rows are called period. We have 1 to about 7 period. 1 to 7. Okay. So like I told you, element in the same vertical column, the same group have the same number of electrons. So the one on top of group 1 actually stands for the number of electrons in the outermost shell of each of the atoms in that group. So 1 represents 1 electron in the outermost shell of the atoms. 2 stand for 2 electrons there. So 1 and 2 are part of the A group, group A elements. All right, so I would like to jump group 3 to 12. Group 3 to 12 will not be done at this time. These are B group elements. Okay, so I'll jump to 13. Group 13 is otherwise referred to as group 3. So each of the elements in that group has 3 electrons in the outermost shell. Group 14, also being referred to as group 4, has 4 electrons in their valence shell. 15 have 5, 16, 6, 17, 7, and 18, 8. Okay, so group 1, 2, 13, 14, 15, 16, 17, 18 are called the A group elements. They are the main group elements. 1, 2, 13, 14, 15, 16, 17, 18 are the main group or the A group elements. Okay, while 3 to 12 are the B group elements. The B group elements, which we also call the transition metals and and inner transition metals. So, all right, now lithium, sodium, potassium, rubidium, cesium, and francium have something in common. They react the same way. They react the same way. Okay, they have one electrons in their valence shell and they can lose that electron to react with non-metals. All right, so now let's look at the types of elements we have on the table. There's what we call the boundary line. If you look at group 13, there's a bold staircase-like line, bold line that looks like a staircase. That is called boundary line. So that boundary line demarcates the element into metals and non-metals. So elements on the left-hand side of the boundary line are metallic elements. So they are all bluish in color, while those on the right-hand side of the boundary line are non-metals. They are non-metals, and they are kind of lilac in color. Then we have those that are along the boundary line, those that have that are yellow in color, boron, silicon, germanium, and the rest are metalloid. They are semi-metals. They are semi-metals. And then we have some series of elements down the table. The first series are called actinide, and the last series are called lanthanide. We're not looking at these ones today. We're only going to concern ourselves with the main group element, that's the A, 1, 2, 13, 14, 15, 16, 17, 18. Okay? All right, now group 1 elements have a unique name. They are called alkali metals. Group 2 are called alkaline earth metals. Group 13, we call them boron family, 14 carbon family, 15 nitrogen family, 16 oxygen family, 17 halogens, and 18 noble gases or rare gases or inert. We'll talk about the properties, periodic properties. Periodic properties, that is the properties of the atoms that change regularly across and down the table. Properties like atomic radius, ionic radius, ionization energy, electronegativity, and electron affinity. All right. Thank you guys for watching. See you in the next class where we shall take some questions on this topic. Bye-bye. Yeah.